Good morning, I'm Manuel Zarzo, and we are in Unit 6, Inference in one normal population. Today, in this video, I will talk about how to compute the interval for the population mean. Well, confidence interval for M. How to calculate from a sample an interval containing with a high probability the unknown value M of the population mean. Well, this is the target that I will answer in the video. Well, we have this formula, okay? So the sample average, this is x bar, okay? The sample average minus m divided by the s divided by the square root of n follows a student 2 distribution. Then it means that with a probability 1 minus alpha, this value will be comprised between two critical values, okay? The values that we read from the t table, reading at alpha halves, okay? Yes, and then we have this, that this is the statistical parameter follows the student t distribution. So therefore, then we multiply, this by the critical value, and then we have this, that the sample average minus the critical value of the t table having an area of alpha halves on the right side, multiplied by the standard deviation and divided by the square root of n, okay? So x bar plus or minus, okay? This is an interval that contains a probability 1 minus alpha, okay, of containing the real value m, okay? So this with a confidence interval 1 minus alpha, okay? This confidence interval has a probability 1 minus alpha of containing m. Remember that alpha is called significant level and 1 minus alpha is called confidence level, okay, for this reason. So this interval contains with 95% confidence level, 95% is the most common confidence level of containing the real value m. Okay, 1 minus alpha, confidence level. So what happens if sigma is known? Well, this is not very often, but instead of the critical value of the t, we will use the critical value from the standard normal table. Good. So an example, following with the example that we were explaining in the previous video, we have this. So the sample average plus minus critical value of the t was 2.14, standard deviation divided by the square root of n was 15. So we have this lower limit on the left and the upper limit. So the confidence interval for m with 95% confidence will be this one. Good. So what is the practical interpretation of this result? Okay. So actually imagine that SRS remembered simple random sampling. So I take a sample at random, and based on the sample I make the calculation of this interval, and then I do this several times, okay? I do that a lot of times. Well, so from the first sample I compute the interval applying this formula. From the second sample I apply the formula to obtain the interval. So most of the intervals will contain the real value m, and just a few of the intervals will not contain the real value m. In practice, in particular, 1 minus alpha percent will contain m, and alpha percent will not contain m. Okay, so as alpha 5% is the most common, we can say that there is 95% probability that the true value of m is comprised in this interval. Okay, so hypothesis tests for m using confidence intervals. So based on the confidence interval of m, I can also solve this hypothesis test. Okay, it's just quite simple. Just if the value of the null hypothesis is inside the confidence interval, okay, we will say that we cannot reject. And if the value is not inside, we will say that we reject. And then we will accept the alternative hypothesis. So it's just as simple as that. In our case, the null hypothesis that we were considering was 2000. So can we say that the sample comes from a population with average 2000? Well, yes, in this case, the value 2000 is comprised inside the computed interval. So the conclusion is that we cannot reject that null hypothesis. Okay, so it's reasonable to say that the population mean is 2000. So don't readjust the machine. So we don't have enough evidence to say that the machine filling the barrels should be readjusted. Okay. Imagine that we consider the null hypothesis m equal 1990. Well, the conclusion would be the same. Or 2003, again, the conclusion will be the same. Okay, same. So should we readjust the machine because it feels different from 2000? No. We don't have enough evidence. So, but have we demonstrated that m is equal to 2000? No, not again. Okay, so when we say that we cannot reject the null hypothesis, we're not saying that we are accepting that m is exactly equal to 2000. So it's better to say two possibilities in the hypothesis test: reject the null hypothesis or do not reject. This is the way how star graphics works. Okay, so the confidence interval contains all null hypotheses consistent with the obtained sample. Yes, and here I finished this video about how to compute an interval for the population mean.